All right, what are we doing?
Um, well, I sent a quick note over. I hope it's not like a boring topic or
Yeah,
anything. I'm open to doing whatever you want, obviously. But I
yeah, that
was
sounds good.
laughing that I'm sort of, I'm starting to run out of fundamental stuff to talk about. I mean, we could, can always dive into the details of some specific, sector that's likely to be disrupted or whatever. We can get down in the weeds, and if that's something that folks are interested in. But if we're keeping it at sort of a high level, an overarching conceptual level, then I'm afraid I only have so many ideas to really talk about. But one that we haven't, sort of fully explored, but we've touched on a few times, and one that I'm really interested in understanding better is this the potential for human labor to be disrupted by automation. Because on my team, this is something we've shied away from, doing a proper research dive into. But I think it's
Mm.
likely to be as fundamental or more fundamental than the disruption of energy and transportation and food that we've already looked at. And I see it as sort of an extension of the sort of ongoing information and information technology disruptions that have sort of um, continued to occur, overlapping with one another again and again over the last over many decades now. So but this is something where I don't feel like I have a very good handle on the state of the technology, its real trajectory, its potential for cost improvements, for you know um, basically just what the next 10 to 15 years really looks like, from a proper expert point of view, like you guys have, as far as machine learning and narrow artificial intelligence and automation and robotics really goes. The it's easy to get a misleading view of that just reading uh, non-scientific publications and just paying attention to sort of the discussions that people have. That I don't, in other words, I don't feel like I have a very reliable view into that world yet, and I'd like to get a better sense from you guys of what we really think is plausible to expect over the next 10 to 15 years in that domain of technology. And then, if we want, we can sort of think, okay, well, between here and there, what do relationships between labor and the rest of society, especially capital, I'm thinking of, but I mean, you can think of other things that labor is part of or relates to, institutionally or culturally or whatever. We can talk about how we think that might change, and not necessarily just leaping forward to the end point. That's the temptation, right? Oh, well, let's just imagine a future where everything's automated. That's easier to do. It's been done a lot. I'm more interested in what I think is the harder part, which is what are the steps? What are the incremental steps actually look like between here
Mm.
and some moment in time at some point in the future where a great deal of what is currently undertaken by human drudgery and toil has been successfully automated. I'm interested in the steps between here and there, not necessarily just envisioning the end picture, although that's perfectly fun, of course. So anyway, that was the sort of thing that I was hoping to talk about, starting with this, getting a handle on where we really are with machine learning, machine intelligence, the potential for machine labor, and automation, and what you guys, with a properly expert view, really think the next 10 to 15 years looks like there.
Yeah, cool.
Is that fair enough?
Yeah, sounds good. I'm just thinking about where to start. I guess maybe this is true of many trends, but it's both simultaneously overestimated and underestimated in some sense, right? So, yeah, it's difficult to talk about. Maybe I'll just list some of the things I'm tracking personally in the domain of automation and manufacturing, which of course is heavily automated already. So maybe we should be clear about what kind of automation we really mean.
Mm.
So, and it's it's maybe not so clear that it's a binary, right, where it's like a certain kind of automation now, and then something will happen and it becomes a different kind of automation. It's not really like that. It's more like there are many tasks. I mean, you take a typical factory, there will be some tasks that are people have formulated specific machines to perform them, like to make Pringles or whatever. There's some very specific, it's basically an algorithm in physical form that somebody spent a lot of time figuring out, and then they built it, and then it makes many copies of a given thing. But the production line is arranged so that the inputs to that machine are of a very definite form. So there's a certain density of very standard objects going into it, and they're controlled in speed, and they're checked for defects before they enter the machine and exit the machine, because the machine is has very low tolerance. It's really like an algorithm that accepts a certain kind of input, and if it's not exactly that kind of input, then it just will break or not do anything. So, however, that automation process can be so valuable that we've arranged a large percentage of human labor to be checking the inputs to such machines, checking the outputs from such machines, and then basically plugging such machines into one another. Whether that's circuit board assembly or maybe I'll I don't want this to be a monologue, but here's if you think about machines do a lot of the manufacturing already, right? Where it's kind of some percentage of the the humans are sort of in between the machines in a typical factory, checking and doing certain sort of integration tasks. And it seems to me like the place which is most vulnerable to automation in the short term are the kind of sorting and integration tasks that require some kind of basic visual reasoning that is now within the scope of deep learning tools. So most famously, Amazon runs competitions on this, which have in recent years been, what's the name of the startup? Coherent, I think. I can check, but this is Peter Beals. I think I've got this right. There's a deep reinforcement learning is starting to have an impact on manufacturing. We have fairly cheap cameras combined with deep reinforcement learning, which accumulates training data at scale, so across many installations of a robot to perform things like sorting. So Amazon is very interested in this, right? So for their logistics facilities, they have many objects, and you want to put them on a conveyor belt, and they're different sizes and shapes and textures, and you want some sort of robotic arm to just pick them out and put them in an appropriate box for sorting and delivery or whatever, right? And that's a task that until recently you'd need a human to do, because humans would be pretty good at that, right? At some speed, there's objects coming along a conveyor belt, and you tell the human, put all the, frisbees into this box and all the books into that box. But because they're of uneven, a book is a hard thing to define, right? So, they can be of many widths and many sizes and come in many orientations and so on. But that's the kind of fairly routine component of manufacturing which is now being automated. There's several startups doing that. I don't know how, I don't know enough about manufacturing to know what percentage of manufacturing activity is sort of vulnerable to that stage of automation, but that's what's happening right now, I guess.
Okay, that's really useful. That's interesting. Seeing behind the scenes, where these machine learning technologies are really being put into practice would be very interesting. I need to do more reading, and basically more study to see where these things are going into effect. So that's a great example. The sorting in Amazon warehouses. I have heard about, of course, automation with mobile robots. These little carts that effectively that drive around Amazon warehouses,
right.
and I think they do reasonably sophisticated tasks of navigation, pathfinding, and avoiding one another and obstacles. And I think it started out fairly rigidly defined, what they were able to do. They're basically running on rails and very, quite limited, quite limited, I don't know what the right word is, algorithms or you're basically just running procedures that were fairly simple. But I think those have gotten more sophisticated over the last few years. And now it's possible to really just, tell the robot to go get something from the back of the warehouse, and it will just go and manage to make its way over there and find it and bring it back, kind of thing. So I guess I sort of forgotten that Amazon was a real leader in the actual adoption of these technologies here at this early stage.
I think they acquired the startup, one of the big ones that was making those devices. I spelled this guy's name wrong. Yeah, there's a good podcast, actually. I highly recommend it. Which is called the Robot Brains podcast.
Robot Brains. Okay, got it. So giving a couple of examples, just maybe to help with some context here. So obviously we watch the self-driving, the autonomous driving technology space pretty carefully. That has major implications for transportation and the work that we've done there. Some of the scenarios that we've analyzed have assumptions about self-driving technology built into them, so that's something we're obviously paying attention to. But then another thing that I've seen recently, and actually just had quite a poor experience, I have to say, is that there's a lot of there are a lot of attempts to automate, to maybe cash in on this idea of automating certain things. So I recently bought a pizza out of a vending machine. Huge mistake. It was just awful. And the problem was that my expectation was that this machine was actually making pizza, and it turns out it isn't. It's not a robotic kitchen, which is what I was sort of led to believe. This is a startup. They've got a storefront in Ann Arbor here, so we just went over to check it out. We got a pizza. It was absolutely terrible. But it isn't that the machines are making pizzas. It's the pizzas are made off site and by people and frozen, and so it's just a fancy vending machine that microwaves or whatever warms up a pre-made frozen pizza. It's nothing. So that's not what I'm talking about at all. That's just I don't mean to rubbish it completely, although I still have literally a bad taste in my mouth from that. But I don't mean to rubbish those efforts completely, but that's obviously not the sort of thing that we have in mind as being disruptive. That doesn't quite fit the criteria, obviously. It really is this idea, like you were saying, Dan, where there's some set of tasks that, for a variety of reasons, were required, for lack of a better word, intelligence in order to accomplish some tasks that are that require some sophisticated reasoning visually, or other pattern recognition that requires navigation, maybe modeling the behavior of other agents in some constrained or limited way, to avoid getting into collisions or other trouble in some real world space, so presumably some three-dimensional space. And a lot of these sorts of things are typified by what vehicles have to do if they are going to successfully drive out in the world. But one can imagine many work environments where even from a human perspective, it's quite repetitive and boring, and obviously if it's dangerous and it's just toil, it still requires a lot of brain power, a lot of real thinking, in the same way that driving does. And so it's really that sort of automation that obviously is where my real keen interest is. And so let me add one more thing here.
Repeat that. What kind of automation is where your keen interest is?
It's basically what I just described, which is this automation, this automation of tasks that from a human perspective seem simple and seem boring, and they're basically toil and drudgery. So I'm not talking at this point about automating, this perhaps the so-called professions, right? So doctors, lawyers,
Sure.
Architects, those sorts of things. They're not talking about necessarily automating what human beings perceive to be intellectually demanding tasks. I'm talking about automating what human beings perceive to be repetitive and boring tasks. But obviously, there's a very large number of jobs in the global labor market that are
Sure.
like that. And so I'm actually very interested in understanding. And this is not to say that both the automation across all of that could occur simultaneously. Perhaps it can. Maybe perhaps some of the professions are more vulnerable in some ways. But it's in particular the toil and drudgery automation that I'm quite interested in. So that's what I meant by that. And let me just let me just add one more thing here let me put one more thing on the table, just as an idea to think about. It occurred to me a while back that well, actually, I tell you exactly when it occurred to me. It occurred to me when I first saw this announcement about Tesla developing a humanoid robot. And, I had a mixture of feelings with seeing that at first, a little bit of obviously some skepticism and so forth. But, I think it has potential. So I'm taking the idea, and the prospect of that seriously. But this was the idea that occurred to me. It occurred to me that we've done two things in optimizing production. So basically manufacturing, but maybe even production more broadly. So production of services and so forth, but especially manufacturing, making stuff. Okay, we've sort of optimized that, at least to my mind, we've optimized that in two different ways that are relevant here. And the first way is what you described already, Dan, where we have very narrowly defined and constrained and controlled the scope of a set of tasks and its inputs and its outputs, right? So that it's amenable to mechanization, perhaps is a better way to think about it than automation, where you can use machines that are dumb, but they can do the same thing over and over again, very precisely, very, very, with great strength, with great speed and so forth, faster or stronger than human beings. But they're too dumb to do anything but the same thing over and over again. So what you have to optimize is some very, very, very tightly defined and limited activity. Okay, we've done that. On the one hand, we've done that kind of optimization. It's a great success. The other thing that we've done is we have at least this is hypothesis, and it seems fair to me. I think we have optimized production around human labor, and basically we've set up processes so that everything is optimized, given the assumption that human beings are available to be part of this, whatever the system is, whatever the manufacturing operation is. So we've basically built all these factories and all these facilities and all these processes with the assumption that there are people who can do this, who can do whatever that needs to get done that today only people can do. I think that's kind of a truism. And so what I'm wondering is if it isn't perhaps really quite smart to focus on a humanoid robot that can just drop right into the role of humans, because we've already optimized so much around humans, literally around the human physical form in many factories, but and it's certainly in terms of like the tasks that a person can do with two arms and fine figures on the end of each one, and two eyes and on two cameras on a gimbal that can move around and that kind of thing. And so I'm wondering if it does make quite good sense to try to design robotics to fit into what we've already optimized, rather than go the other route, which is to introduce a robot that's been optimized by some other criteria, and then redesign and optimize all of the other rest of the manufacturing operation around some new intelligent labor agents form. Do you see what I mean there? So
Yeah.
I don't know if I'm doing a good job of sort of describing that idea. But that's yeah, because traditionally I've always heard, well, why would we make robots that look like people? That maybe that's not optimal. Why wouldn't we build them on wheels, and why wouldn't we give them 5 arms instead of 2, and et cetera, et cetera? Why would we be constrained by what we've already? And one good answer to that may be that, well, we've built just about everything in the in the economy to fit very well together with the human form, and so maybe we don't have to do much re-optimization if we just roboticize the human form. Anyway, it's just a hypothesis. I don't know if it holds a whole lot of water, but it's something I've been thinking about. So
yeah, I think I'm a bit skeptical of that, simply because the complexity of getting a humanoid robot to work is really extreme relative to getting more task-specific things to work. I think so. Rodney Brooks, who's a famous roboticist, is often quite scathing about the more optimistic projections for robotics. And I think there's some value to that. So he's not only a famous academic, but he started several companies. Rethink Robotics is one of them. I think the company he founded is the one who built the Roomba. I might be wrong about that. So that's one of the few robots to actually survive being turned into a product, right? Let me check.
Yeah, that's true. It's a good point. And obviously, there's nothing like the human. It's not like a robot that's walking around behind a vacuum cleaner. Yeah.
Yeah, and they designed, I think it didn't quite succeed in the market, but there was a robot called Baxter, which had a kind of iPad face, and you guided the arms to do things, and it was meant to be exactly what you're kind of suggesting. So you'd have, it was designed for not enormous companies, but companies that could benefit from automation. And there's clearly a market there where if you're a very large company and you can afford to spend, $10 million to automate the production of some little widget, then you can do it. But if you're let's not say medium size, well, maybe medium size is appropriate. I mean, you still have some resources. You can drop $20,000 on a machine, $100,000. I don't know how much they cost, but maybe you can't afford to hire a team of engineers and roboticists to automate your process. But maybe your process is, in a sense, not that complicated, right? You got a conveyor belt set up and you need to sort something, or I don't know. I'm not a manufacturing person, but so they designed this robot Baxter where you'd kind of train it what to do, right? You'd move its arms with your arms and show it what motions to do. A bit like Automator on the Mac, or I guess there's a Windows equivalent where you're operating your apps, your programs, and you click around and you just record it and then you play it back, and that's a kind of automation. But you could hope to do that in the physical world. That's kind of what Baxter.
It's funny that I'm not a Mac user, so I'm not all that familiar with that on the Mac. You can do that. You can record those sorts of things in individual apps, like the Office environment for Microsoft. You can record what are called macros that kind of do that a little bit. It's funny. I remember having an idea to do this operating system wide, have a sort of background application running that would do this across all input and all programs. I remember thinking of that idea with a friend in the early 1990s and wondering how possible it would be. We looked into it and decided it would be totally impossible. So I completely forgot about it. And the last time I thought of it was at least 10 or 15 years ago. It's funny you mention it. Sorry.
Yeah, anyway. Apple's had some version of that for quite a while, but the latest version's Automator. I'm actually running it right now on the machine that's recording. It's pressing W every 15 minutes to walk forward so it doesn't get logged out. Nice. Which is a very sophisticated automation. Yeah. But you could imagine a version of that in the physical world, but the Baxter robot didn't really succeed, I think, in the market. I don't know if that says anything, but what's to say about the Tesla robot? I mean, people like Rodney Brooks have been very dismissive of that and kind of made the argument that you almost need to solve every problem in AI to make something like that work. So it's like a lagging indicator of the transition to automating intelligence rather than something you'd expect near the beginning. I think there's
that makes sense.
some kind of, I mean, one should always be a little cautious in, the old saying that if an old expert says something's impossible, it'll be done quite soon. And so I think maybe one should, not be completely closed-minded about that. But I think it is, well, maybe this is off topic, but the argument for sort of being optimistic about the Tesla robot that I've seen is simply the fact that they don't exist. You might, it's a strange situation with the robots that people use to, say, train deep learning models. There's kind of very few companies that make standardized robotics like that, that you could buy to work on. It's kind of strange, right? That you might think there should be heaps of people making standardized robotic arms that you can go and buy and try and train to do something, but that's really not the case. So probably Tesla ends up, maybe not making a whole robot body, but maybe they could really make a great robot arm and a great robot torso or something like that. I don't know.
Yeah, I guess that's brings an important dimension into it, which is, if even if it made sense to have a custom-made robotic form for whatever specific operations you were undertaking, manufacturing or whatever else it might be. I mean, even imagine a retail operation. You're selling clothes in a shopping mall or something like that. And what does the robot need to do? It needs to be able to pick up clothes, fold them, put them on the shelves, unbox things, whatever the various tasks are. Run the cash register, mop the floors, and open and shut the shop, and all that sort of stuff. And one can imagine that there might be a form, non-human form, that would be more optimal for those functions than the human form. But would the cost of developing that entire form be worthwhile if you could just buy a Tesla bot and the Tesla bot could do a pretty good job of it, because all of the shelves and everything are already set up so that human workers can do it? And so I guess there's this factor of will there be a market for the production of lots and lots and lots of different customized, specialized, purpose-made robotic forms, or that seems to me to be one sort of a tractor basin in the possibility space, and another tractor basin is that we instead, everybody just figures out how to make the best in their whatever their situation is of some standard form that's available. Maybe one or a handful of standard forms, one of which presumably might have some humanoid elements to it, and maybe another one might be some wheeled thing with a flat surface on the top that you can put stuff on top of. I'm thinking like the robotic waiters we've seen in science fiction movies forever, right? It rolls up and it's a tray on top of wheels, basically. And you could imagine a handful of sort of general platforms that then everybody else is designing their processes around, as opposed to, okay, I've got this process, I need a special robot for this, and then. But I mean, that's an assumption. I could see it, potentially going both ways, especially if maybe the design and production of robots becomes much more efficient and affordable and cheap, and I don't know.
Yeah, I think that's right. I think that we're likely to see some kind of limited but not specific platforms reach scale at some point, probably within 5 years or so, and maybe I would bet on something like what Peter Rabiel is doing with his company.
So why do you say 5 years, Dan?
Yeah, okay. So here's some background knowledge that's going on in my head. So if you look at the second board, I'm going to sketch something. So there's a couple of ingredients you need to do. Yeah, I think mechanization versus automation is a good way of talking about it. So what Coherent does and similar startups is they have robotic platforms which are not, they're kind of they're able to do a fuzzily defined task, but it's still a specific task, right? Maybe that's sorting some specific classes of objects, or maybe it's looking for faults in some item. So it's it's kind of not a general task, but it's also not as precisely defined as the old-fashioned manufacturing automation would require. And the fuzziness there is possible because of things like deep reinforcement learning. So that's the same technology that's in AlphaGo, for instance, or AlphaStar. And then there's, of course, improvements in the physical engineering of the robots. I don't know that there's been necessarily a lot of breakthroughs in that. Maybe there have. I don't know. So the combination of these two is what is sort of seems to be driving some of the progress. Things like these robots that run around in Amazon warehouses, I think they don't really have any deep learning in them, or maybe very little. Maybe there's a little bit of computer vision, but it's more like old school. There's a lot of very capable AI that was developed for robots and hasn't changed much, and that's what Roomba uses, and works very well for what it's doing. So I think there's a lot of, one has to be a bit clear that a lot of the progress in automation is more like Amazon has reached a large enough scale to invest a proper amount of money in technologies that were already well understood for decades, but nobody really tried to deploy them.
Yeah.
Versus, there's like really new technology that people are making use of. The two, because the money and so on available at scale for tech companies is, just it keeps increasing exponentially. The money is being made available to both sources of innovation at the same time. So it looks like maybe it's a single trend, but it's in some sense two, I think. I mean, they're related, of course.
That's an element of our theory for disruption, where we have the convergence of multiple threads of technological advancement, and sometimes one of the threads can exist for a very long time before it sort of it converges with some other thread of technological advancement, and then circumstances too. Availability of capital is one, market demand, potential sort of breakthrough product is another. So yeah, it's all quite familiar.
Yeah, so one of the reasons to be kind of bullish about deep RL in robotics, I think. I mean, it's very difficult. People have been trying this ever since I paid attention to the field. So I don't know. It's at least at least 6 or 7 years. Deep RL for robotics has been a thing people have been doing. You would have seen the Rubik's Cube that OpenAI did. How do I spell Rubik's? I don't know. Yeah. So there have been some kind of milestones in applying deep RL which is a particular kind of deep learning, to robotics, but I think there's probably a trend happening in deep RL that, when translated to robotics, will potentially unlock rapid progress in the way that we've seen happen in computer vision. That was the first place where deep learning, of course, took off, and that was as a result of neural networks themselves, but also this large training data set, ImageNet. And then arguably the next big step for deep learning, which we're in some sense in the middle of, were language models based on transformers. So that's a particular kind of architecture. So that's things like GPT-3.
GPT-3, yeah, I was going to say that's the one I read about the most in the news is the GPT-3.
Yeah, and the phenomena there, it's not just the architecture, but it's also the kind of practice of what what's sometimes called pre-training. So the discovery here is not so much the architecture, it's the fact that you can pre-train one very large model. So it's very expensive to train it. You train it on, that's something like all the English on the internet, or something approximating that, right? So a really large data set. You pre-train it with a very generic task, like predict the next character. So it's not task specific. So that's what people mean by large-scale pre-training. So it's a very generic, sort of unsupervised task. You're not asking it to predict whether a given piece of text is happy or sad, or any specific task. So you pre-train a very large model like that. And then you can just use it to do many specific tasks, or you can even fine tune it to do a specific task. So sentiment recognition, predicting whether a review is happy or unhappy would be an example, but there are many other ones. And now that's a very important approach in computer vision as well. So this idea of pre-training is a very important one in modern large-scale deep learning. Now, to date, this approach has not worked in deep RL, really. I mean, there have been some recent progress, but what you really would like, and this is the kind of the holy grail of deep RL, is to have this kind of language moment, but for deep RL, where you have some enormous corpus of tasks that an agent might want to do. Now, in the case of robotics, this might be, you have 600 million years of simulated stuff an agent might want to do. Every task available in a human home, driving, blah, blah, blah. You just invent heaps of tasks. And then you train a kind of large model to do all of those tasks, or at least to, maybe not to do every specific task, but you train it to do something which you think is kind of upstream of being able to do any one of those tasks, whatever that might be. Maybe predicting what happens if you take a certain action. And then you hope that you can just fine tune that single, very expensive model to do many specific tasks. And
interesting.
And I think we're kind of on the cusp of that. So there's been some results in that direction. You may have seen DeepMind's, maybe we discussed it, I don't know. I can send you a link, but about a month ago, there was a paper out of DeepMind where they trained an agent in, thousands and thousands of games, not any specific game, and then observed certain kind of generalized learning and exploration behavior emerge, which could then transfer to a game that the agent had never been trained on, literally different rules. So that's an indication that this kind of pre-training is possible for deep RL agents at sufficient scale, and very few companies can afford that kind of scale. Actually, I'm not quite sure how expensive that particular experiment was, but to do it for something that would approach useful for robotics would be, extremely expensive. But okay, just today, DeepMind posted something about fusion. I don't know if you saw that yet.
I saw that. Yeah, I saw that. They're actually, it's interesting. There's a science fiction movie. It's a mediocre one, but it's called Passengers, and I forget who is in it. Chris somebody or one of the.
Oh yeah, I've seen that movie. Yeah. They're asleep and then
they're asleep and he wakes up or something.
Yeah.
One of the premises is that the computer gets damaged. The ship gets struck by some object as it's traveling at high speed, high sublight speed, and its shielding fails and the computer gets struck. And so one interesting thing in the premise was that it apparently required a huge amount of computing horsepower to figure out how to contain the fusion reactor, and so the systems are failing because the computers are struggling to keep up with maintaining this damaged fusion reactor. And it seems a little silly, but then I thought, that's actually not a bad idea. It might actually be something that requires it may be that you need some very sophisticated, extremely high speed system in some sort of intelligent response kind of system that's watching and responding in real time to containing a very complex and changing sort of reaction. And because I was aware that was a real challenge in the fusion reactor systems is this how do you make adjustments in a millisecond to millisecond to things. Anyway, surprisingly prescient. Science fiction sometimes gets lucky with things. And that, of course, as soon as I saw the article today, I thought, oh, that's interesting. That wasn't such a goofy idea after all. It's in some ways it seemed a little silly in the movie, and you accept these things as part of the as part of the premise of or whatever. Suspend your disbelief, but it is funny when in retrospect things actually turn out to make a little bit more sense maybe than you originally thought they did. Sorry. Anyway, yes, I did see the article this morning and made me think of it.
Mm-hmm. Yeah, it should be clear. That's not, as far as I know, an example of this large-scale pre-training I'm talking about. It's just I think deep RL, even among the deep learning community, had a reputation for being a kind of stupid toy thing that would only work on games. Like real grown-ups use deep learning in computer vision or language, and it's only the weirdos at DeepMind that do deep RL and dream that one day this might be useful for something.
Was there a specific reason why the reinforcement learning was not seen as having as much potential as other forms of other forms of deep learning, other forms of machine learning? If there isn't a simple answer to that, it's no big deal. But.
Yeah, it's a good question. So actually, Geoffrey Hinton was kind of famous for being not so optimistic about deep RL. I think it's partly it's because in deep RL, there's kind of a technical reason. So in deep RL, you're training an agent to take actions in an environment, but what they're learning from is their past experience, right? But that past experience becomes outdated as soon as you improve. So if your ability to play a game improves, the distribution of games you experience is different because you're now like experiencing amateur games, whereas before you were experiencing like really stupid games where both you and your opponent, which maybe is you, are just playing random moves, right? So what that means is that you have to generate your own training data as you go. As opposed to something like computer vision where you have a fixed corpus that you're training your network against, mapping from images to yes or no, whether they contain, a fire truck or whatever, but it's fixed. So there's kind of a sense in which you can spend the money once to get this data set, and then you can train many networks against it. Whereas deep RL is this kind of related, but it's a kind of like an economics difference, which is decisive, right? So that's why it's so expensive to do deep RL, because you have to keep generating your training data. You can't just train, you have to generate the data. You actually have to simulate the world that the agent is in. And that's why it's really expensive to train an agent to play StarCraft or Go, right? Because you can't. The problem is not just to map it's not just to learn a function. It's to learn a function that is conditional on the current agent, and that agent is changing.
So there's some sort of recursive dynamic that creates that it sort of explodes the data requirement a bit. Is that what's?
Yeah, that's right. And you trade computation for data. That's how people often talk about it. So.
Sure, that makes sense. Yeah.
But that computation is whereas the data cost in the case of supervised learning, like ImageNet or languages, in a sense, you can spend that once to get a big data set. But in deep RL, first of all, you have to create the data, so you spend compute to get the data, but then you have to keep spending. You can't just spend it once and be done. So that's kind of why it wasn't obvious that the fine-tuning or large-scale pre-training approach could work in deep RL, right? Because, it's like you'd have to go out and collect all the English on the internet, but then you'd have to go and do it again, like as soon as your agent got a bit better at English, and then you'd have to go and get it again, and that's not really feasible, even for people with deep pockets. Well, those are two slightly different issues, right? There's the question of whether deep RL will ever be kind of practically useful, but the fusion thing just settles that. That's over, right?
Interesting.
So it's useful. The second thing is, can large-scale pre-training work in deep RL? And there's hints of that, and I think there's no reason to bet against it. So I bet that it's true. That means that, and then there's a third ingredient, which is, well, can you actually use these agents to control robots? Well, that's true. OpenAI has shown you can do that. What they did has many caveats, and there's reasons to be, they hyped it a bit too much, etc., etc. But fundamentally, it works. So if you put all those three things together, I think that there's the stage is set for a kind of step change in how well deep RL can work with, suitable simulators and suitable devices that are built specifically for it.
Do you think that, I mean, this is, maybe I'm naive, but this is sounding a fair bit like what Tesla is talking about. They've just made this Dojo supercomputer system, which is specifically designed to not just for the various machine learning stuff that they want to do, but a big part of what their description there is simulation. They want to be able to generate. They want to be able to generate and take the real world data that they're getting from their fleet. So they've got they get a lot of data pouring in from there, and then a second sort of parallel thing that's going on as far as data goes is simulation, creating a lot of data with simulation. And my understanding is that they're designing their own supercomputer system to do that, the combination of those things and some other things as well, I guess. And then you've got this humanoid robot that, I don't know, it sounds like they're putting the pieces together.
Yeah, I don't know how that
take
fits
advantage
into
of what you're talking about, or at least it fits. I don't know, maybe not, but
yeah, maybe it just seems like jumping to the full humanoid robot. I don't see how that path connects in the short term. But
okay.
so I mean, that's their deep learning team has some of the best people at doing this kind of thing, and they have dedicated hardware teams and so on. So I'm not betting against them, but I think maybe I'm being a bit cowardly in my predictions. But in terms of what people like Peter Abiel are doing with robots that are kind of not quite general purpose, like a Tesla robot, but still not extremely narrow, like current mechanization in factories. That kind of domain where you have a bit of a messy task in a factory, you need a robot that, I think people will be creating kind of not general purpose, but kind of, broader than the current robotics, using stuff like DeepRL. And this, I think, is going to work. And that will, even in and of itself, well before anything like, I think the Tesla robot thing will take much longer than that, but that will already transform manufacturing, I think, that kind of technology.
Mm-hmm.
And that's, I can't see how that doesn't happen and soon. It's just a matter of moving it out of, I mean, in the next few years, that will kind of be academically proven, and then it's a question of moving it out into deployment and scaling it. And I don't know how long that will take, but I feel pretty sure the wheels are turning in many places preparing for that. Not least in China, where this is a huge area of investment from the government. So,
yeah, I mean you said like sorting and visual reasoning, and maybe in a limited, not very, very broadly generalized environment, but environment that's fuzzy. One of the things that occurs to me that might be a good fit, economics aside, but a good fit for the task would be farm robots. Things like identifying, distinguishing weeds from crops, and identifying when fruit is ripe and should be picked, and just walking, rolling along or moving along, and picking berries when they're ripe, right now we rely on human labor, and it certainly qualifies as drudgery and toil. To do those sorts of tasks, and there are a large number of people in the world, not nearly as many, obviously, today in 2022. Work on, not nearly as many people today work on farms as a percentage of the human population as once did. Our farms are very productive compared to what they were 100 years ago or more, but it's still a large number worldwide, and so that's a very large potential market if you could develop a robot that was cheap enough and that was durable enough. I mean, if you had a $10,000 robot that didn't require a huge amount of maintenance to keep it running, and could run for, I don't know, 5 years or something like that, and you could power it with electricity from cheap solar power, that would start to be very attractive compared to human farm labor, especially if it was effective. In other words, assuming it actually worked reasonably well. And so we may be surprised at where. It's easy to think, okay, well, it's going to be in, an Amazon warehouse, and yeah, and it probably will, and it's easy to think it could be in some other sort of perhaps more obvious applications, but we may be surprised at where the good fits are for these things. And I think, farms and agriculture will be a surprisingly good fit for. You don't need to be too smart, but you can't be that. You can't be. You have to be smart enough. And it sounds like this early stage would be a good fit for that. And anyway, it makes me think of that.
There's actually a centering on.
Sorry, I should say one more thing, which is, and I'm sorry to interrupt you, but just one more thing is, one of the things I'm always on the lookout for, of course, as you might imagine, is where is there a linkage between the three sectors of disruption and the disruptions that we were already imagining, so the food sector, the energy sector, transport, and this one, the one we're talking about now, the automation. And so I'm kind of thinking and looking for those, like where would be a connection between this labor disruption fueled by automation and food and energy and transportation and so forth. So that's mainly the reason why I thought of that. But then it seems like it's a good fit. So.
Yeah, here's another one that in the crossover that you might not have considered. So I think soon we will be genetically modifying food plants to basically give logging data, so that a wheat plant will be emitting various kinds of signals which indicate its state of health and how its growing is going, and if there's any particular problems. Plants signal each other if there's an infestation or they have some disease, but I think quite soon those signals will be available to us.
Wow.
And that we'll be capturing them by things like drones that fly over fields and then processing them, so that basically plants will be able to say, come and spray some fertilizer on me, and then the robot will come and do it. That's
holy shit, that's amazing. You're right, that one's was not on my radar, but it certainly is now. Holy crap. Okay,
but that's not that far-fetched.
Yeah.
Actually, the Australian government's quite enthusiastic about not surprisingly, we have a large agricultural sector, and it's that's something they really want the big brains in Australia to be working on, is helping to improve the productivity of the farm sector by exactly the kinds of things you're talking about. Yeah, it seems to me like there's just like a lot of latent stuff to be done, where the business models need to be worked out, and how do you license the IP, and who repairs the robots, and where do you build them, and all that stuff needs to be sorted out. But like, there's a lot of stuff you can do right now.
Well, I mean, I don't mean to sound either flippant or intellectually lazy about it, but in our experience looking at both the current big disruptions we're seeing starting to unfold now, and then the ones we see throughout history, those details, the logistics, and they are real and they are legitimate concerns, but they tend to, in a big, noisy, global, competitive economy, those challenges are the sorts of things that tend to get solved as a consequence of just good old-fashioned market forces and government incentives and social and cultural pressure. When you put all of that stuff together, that's sort of where there's a will, there's a way kind of thing. Once the key new technologies do emerge, I hesitate to call them breakthroughs, but once the key technologies emerge, and so that maybe again, I mentioned convergence before, the right combination of a few technologies comes together, it sort of sparks a fundamentally new capability, and then that opens up this new space of possibilities of what can be done and what can be achieved. the things that are necessary to support that growth, and the shift, those things really do tend to work themselves out, unless there's a real fundamental constraint that just bottlenecks and sidelines the whole thing. And that does happen. It's not very often, but it has happened in a few instances. But for the most part, those challenges, we do manage to get those solved. We take those things, logistics and supporting supply chains and value chains. There's always hiccups. There's ups and downs, and we see that in solar, for example, and whatnot. But in general, those things tend to get worked out. So I don't want to be dismissive about it, and we do pay attention to it. But having said that, I wouldn't bet against this technology on the basis of any of the sort of the feasibility, that in the sense of putting the infrastructure in place, building the supporting the supporting markets like maintenance and installation and upkeep and waste management associated with the new technology. All of those things do seem to quite readily emerge. And there's a bit of a lag, and that's probably why it takes some time for these things, for the disruptions to roll out. They don't happen, instantly. But unless you can identify something that seems like it's a fundamental obstacle, that stuff does tend to get sorted out, and sorted out surprisingly quickly. I mean, it's amazing what the availability of capital and the motivation of people to multiply it and profit. It's amazing what that will do to really get people busy as beavers trying to sort this stuff out. So anyway, it's fascinating that plant. It's gonna be rattling around in my brain now. I'm sure this idea of genetically modifying plants to actually signal various data about their status. That's unbelievable. Holy moly, very cool. Dan, you said you had a hard stop. I noticed it's an hour. Do you need to take off?
Oh, that actually got cancelled, so no, I don't need to head off immediately, so no problem.
Well, I didn't mean to interrupt you. Go ahead, please, and finish your thought there.
Yeah, I guess you could kind of think about the way in which we're symbiotic on machine intelligence currently, right? Where we have various interfaces and we outsource a lot of routine calculations to machines. You could imagine enabling if you think about the agricultural economy as kind of like a gene-based manufacturing system, right? That's out there processing inputs and doing stuff for us in a very different way to our metal-based manufacturing system. But the gene-based manufacturing system doesn't really have access to external computation in the way that the metal-based manufacturing system does. But that seems like something that will change pretty soon in various ways. I don't know exactly what that looks like, but there's probably, thinking about manufacturing and automation, I think there's a form of automation that we're probably not thinking about as much as we should, which is the sort of biological automation, where we used to use animals for a lot more mechanical tasks, like using horses and donkeys to pull stuff, and animals used to be a big part of our manufacturing system, and now maybe they're not so much. But as you've pointed out with your precision fermentation story, that animals or bacteria or whatever will re-enter the manufacturing system in a way. I think that's true more generally outside of food, right? That whether through synthetic biology or just understanding existing gene-based systems better, we're likely to fit animals, or I'm not sure if it's appropriate to really call them animals, but let's say gene-based machines. We're likely to fit those into a lot of other tasks that we don't currently think of, whether it's cleaning up mining sites or it's maybe somewhere on the path towards the kind of really far out nano machine that does anything kind of future. But there's probably lots of mundane things that in the short term will get done using progress in that area.
Yeah, I think that makes very, very good sense. And it may be that it may well be that, I think there's some reason to believe that eventually, those sort of general purpose nanomachines are possible, physically possible, and will appear eventually. The whole Eric Drexler vision of atomic level manufacturing and proper science fiction style nanobots, that kind of thing. That I have not really seen the needle moving there. I could be wrong, but I have not seen any signs of any real progress there recently certainly in the last 5 years or something like that. So yeah, it's but where we have seen truly spectacular breakneck pace progress is in biotech. So what are we? How many years are we out now from the mapping of the human genome? About 20. And I guess I suppose, and then plus with all computation and all the rest of it, the convergence again of multiple streams of technology. It seems like we're now really in this space where biotech is just has the potential to make some quite extraordinary leaps and bounds improvements in a number of different domains simultaneously, all of which will have the potential to amplify, cross-fertilize one another. So I think what you're suggesting seems to me very, very, very plausible.
The problem
controversial
right now is
potentially, but very plausible. Yeah.
Problem right now is something like the input output doesn't work, right? So there's an amazing physical computer inside a cell that makes proteins and does all sorts of things. We kind of vaguely understand what it's doing, but we don't know how to program it or even read from it. There's no way for it to really send output to our computers. We can measure, the way we do it currently right now, like with PCR tests and such things, is we can measure the expression of various genes by chopping up the cell and matching little bits of mRNA with some other little bits attached to our machines and counting them, and that's how we tell what's going on inside cells, by destroying them and doing that. I guess there's other means. I'm really pretty ignorant in this area, but I don't think we have a very robust way of even reading out what the state of a cell is in that sense, so that it can send signals out. Maybe optogenetics is a kind of exception there. And we don't have a good way of providing input either. Maybe mRNA vaccines are kind of the breakthrough there. But that seems like, maybe that's very hard, but it's not there's no fundamental obstacles to that, right?
Yeah.
And if you can have robust in and out channels that are real time, well, then why should controlling a cell be 100,000 times harder than controlling a tokamak, right? And if you can do the latter with deep RL, well, why shouldn't you be able to do the former with sufficient effort and resources? And so I don't see why that's impossible. And I don't know how long it's going to take, but seems pretty plausible to me, right? The pieces are there. You just need to improve the biology a bit, and maybe you don't even need. The deep RL system that controls the fusion reactor is actually pretty old school deep RL. It's like LSTMs, and they're very simple networks because they have to run really fast, right? So the innovation there, I haven't read the paper, but my superficial impression is the innovation there isn't. It's like with a lot of what DeepMind does, it's very careful engineering and thinking about the problem and domain expertise, and it's not like some genius step that nobody's ever seen before was necessary. So yeah, why not control cells that way? I think that's coming, certainly. It's just like a matter of time. And once you have that,
holy moly,
it's like anything you can get a cell to do, you can do. That's quite a bit.
Yeah. Astonishing. I wonder how that scales to tissues. and it's interesting because it's that strikes me as being quite a fundamental, a proper paradigm sort of shift in things. So my understanding, frankly, I had not really even considered that what you were talking about was possible. But of course, I think it makes very good sense now that you explain it. But what I had always, my impression had always been that you have to, synthetic design, synthetic biology would have to um, basically basically reprogram a cell in advance, either genetically or epigenetically
Right.
or both, reprogram it in advance and then produce, one or more cells, depending on what you needed. But all that you're basically your programming in your interface would be a single time in advance, and then you have to specify everything in advance. So you have to basically install some complex programming to get the cell to behave a certain way in advance, and then you do it one time, and then you set the cell loose, and it does its thing. Never occurred to me that a completely different way of interface, a completely different way of doing it would be to interface in real time, non-destructively with a cell, and then just instruct its machinery to do things on a sort of as needed basis. And one could imagine a sort of very generic, not blank, but just very generic cells that you then
Right.
plug into an interface with and get them to do, whatever thing you need done at that time, as opposed to, having to program thousands of different kinds in advance for different tasks all in advance. I'm trying to think of a useful metaphor here, but it'd be, I mean, I'm trying to figure out how to make a Lego metaphor out of it, and not really succeeding. But anyway, I
Well,
think
you could think about it as an API, right?
Yeah,
You
of course.
set up
Yeah.
an API for the cells where you can abstract. I mean, I think the point is, and this is maybe the big change that needs to happen in biology, it seems to me, is I think people thought of biology as being like physics, where you need to understand the basic atoms and then you build up your understanding in order to do things. But that seems kind of hopeless. I don't know. Like, these networks are fundamentally complex and they're like holographic. The information isn't in any particular part. It's not actually subject to the reductionist approach, maybe. But that doesn't mean you can't control it, as long as you have rapid feedback and learning, right? So maybe we never understand how the actual gene regulatory networks inside cells are working together in this very complicated way to produce a given result. Maybe we don't need to, right? We just need to learn how to build an API where you send in a certain signal and a certain thing you want to happens, and you don't care. Maybe you don't care what happens inside. That's a difficult pill to swallow, I think, for the reductionist view on science and traditional computer science. It's people in deep learning have thrown that out the door from the very beginning, right? They don't care. Right? That's a thing that really bugs a lot of people, right? That we don't know how large neural networks work. We have no idea, probably, of what this network that controls the fusion reactor is doing. Clearly, it's figured something out. We don't know. Do we care? I mean, as long as it works and we, constrain it so it doesn't blow things up, even if it fails, who cares, right? Like, maybe it's okay. Maybe that fusion system is just fundamentally so complex that that's the only way to control it. And if that's true, then, well, you could just sit there being sad about it, or you could just be happy you can control the damn thing. And maybe that's where biology ends up. I don't know.
Yeah. You're right that the black box element of success in machine learning has it does ruffle feathers, right? I mean, it's sort of like this. It does run a little bit contrary to all of what science has been organized around for the last 400 years, which is find some deep level of simplifying explanation and principle that then gives you unlocks power and control through that conceptual insight. That something may appear complex, but when you unlock its secret simplicity of operating principles, then you can you can control it. And that's been and it's been successful in the marriage between science and technology for centuries. But if you have something that is, what's the right term? I forget what it, computationally irreducible, or sort of just irreducibly complex, and maybe it's hopeless. Maybe it is hope, but maybe biology, social, economic stuff, maybe it's fundamentally just hopeless to try to think you're going to unlock basic principles. I mean, I have to say, when I looked at, sorry, this is a number of years ago now, when I was in grad school, when I looked at econometrics content, like textbooks and papers, and when I was doing my econ courses in grad school, a lot of that just seemed like, it was this desperate hope that maybe we would be able to formulate something useful to say about economies with a few simple equations, and most of it just seemed complete rubbish. Right. Even if there was a grain of truth in it, it was just going to be completely lost in the noise of a real system. And yet, it may be that you could have a machine learning approach that and ultimately ends up being a black box, but that really works. And it's funny. My impression is that Wall Street pivoted completely away from academia and econometric analysis to try to really understand what was going on in markets, and instead just brute forced its way to algorithmic, successful algorithmic trading with machine learning, basically. And that's that seems like yet another example of where, if it like what you're saying, if it works, who cares, right? One might imagine that maybe it is possible to ultimately unlock some deeper level of explanation, unless it's excluded in principle by fundamental irreducibility of complexity or something like that. Maybe if some super intelligent, artificial super intelligence, general AI, AGI, that's super intelligent, maybe it'll actually be able to properly, in the way we find satisfying, understand these things, really, quote unquote, really understand them. But, one can imagine that we could make a staggering amount of progress with, in a way that's fundamentally opaque. And we may just have to come to grips with that,
Yeah, I think there's a kind of machine learning point here, which is worth appreciating, that I sort of notice also in. So string theory is kind of stuck for various reasons, but one of them is that there are many, if you have a model and there are many parameters that don't directly affect the predictions, so that those parameters could have many values and give the same predictions, right? So a neural network is like that. Your brain is like that, right? So you could have exactly the same behavior by, tweaking. There are certain parameters in your brain or in a neural network which they kind of only appear as a product, let's say, like X times Y. So if you doubled X and halved Y, you'd have the same outputs for all conceivable inputs, because X times Y is the same. So that means that the individual values of X and Y, they don't have any meaning. It's pointless to try and explain them, because there's no explaining them, because they don't have any definite values, right? So that's what we mean when we say a neural network is singular or degenerate, and many systems are like, your brain is like that. So that means that actually there is no predicting those values. All you can predict is certain sets of possible values that correspond to the truth. And physics is unfortunately like that too, where if string theory were true, you still couldn't work out the values of the parameters in it, because there are many combinations that would produce the same observable universe. So then in terms of explanation, well, either there's a version of the model where every parameter corresponds to something observable, so it has a definite value, you just can't work it out maybe, but in principle it's definite. Or maybe the universe just has these hidden parameters that they contribute in some way to see what, to explain what we see, but there's no predicting them and no explaining them, because, well, they're not quite the same thing. I mean, maybe you could still understand the underlying structure, even if you couldn't put values to the parameters. But maybe they just that's the kind of ultimate limit to explainability, right? It's just like if the things you observe have inner workings that are inaccessible, then there are many possible models that fit what you observe, and there's no getting beyond that, maybe, right? So I could easily imagine that, I mean, in evolution, nature has evolved certain kinds of mechanisms, say the gene level, that work and perform some function, but the content of that mechanism is irrelevant. It's just some accident that arrived at, after 60,000 years of trying something, 600 million years, some particular thing worked to do a particular job. Right? Maybe that job is like creating a repeating pattern, like 0, 1, 0, 1, 0, 1 at some time interval, and nature hit upon some trick to do that. But the content of the trick is you're wasting your time trying to understand that, right? That's a level of analysis at which it's meaningless to dig into it, because, well, you could spend an entire career understanding every detail of how that's implemented, but nature doesn't even care, right? History could have been completely different, where the mechanism was completely different, and the entire observable history of life on Earth would have been exactly the same. So then there is no meaning to the nature of that system, right? Because it's a difference without a distinction without a difference, right? It's just the information you gain by knowing what's going on there is just useless. It literally doesn't help you predict anything, understand anything. It's just an accident. And how can you tell which details in biology are of that form and which are actually distinctions with a difference? Well, so the approach with machine learning might be something like, let the learning algorithm do, in a sense, what nature did, right? It fits to the thing that's just accidental. And then you worry about dealing with the higher level thing, which actually makes a difference. But I think the objection to employing machine learning in biology is, in a sense, just ignores this phenomena I just described and pretends that every distinction makes a difference. That's clearly not the case. So you have to accept some level of like learning or just dumb fitting to the data. So it doesn't, crying about that seems to me like, you could think it's a binary, right? You either understand it or you don't, but it's always the case that there's some kind of, at some level, the distinctions don't matter, and then you need to understand the level just above that. And maybe that level is higher than we hoped, right, when it comes to biology. So we have to accept some level of unexplainable black boxedness. But that doesn't seem like a fundamental difference to what we were doing. To me, it just seems like we thought the tide was at a certain level, and we find out it's actually at a different level, and we're a bit uncomfortable with that for a while, and then we'll get used to it, and we'll forget that we even cared, I think.
Oh, fascinating. Yeah, well, let's continue this conversation at some point. It's just really, really interesting to think about. I do have to run.
Me too.
I've got Kai squirming on the baby monitor, so I've got to go up and make sure she doesn't wake up. But as always, just amazing stuff to talk to you about, and I love it. So let's
thanks a lot.
Let's chat again. This is fun.
Okay, take care. See you, man.
All right, take care.